by copying someone?
I'm not copying it.
Well, that's really a question. I don't figure out how I did that from.
Yeah,
And
where
I'm
did
sure I
you
could
go?
say
That's definitely
it's
cheating.
at 7.
Where's the teacher?
I know you're not talking about cheating.
I will show triangle. But I can't.
Otherwise.
Oh, I may have made a mistake on it then.
Oh,
I'll have to fix it. Okay. 12.1, day 1, right triangle trigonometry. Doesn't require your laptop, I promise. Okay, so what is trigonometry? Anyone remember? Angles, triangles, sine, cosine, tangent. Specifically, it is the study of the relationships between sides and angles of technically, specifically right triangles. I put the right piece in parentheses because we do trig with more than just right triangles. But it is originally built around right triangles. The sine, cosine, tangent that was mentioned is a right triangle reference. So the things you said, 100% right. I just kind of put them into the sentence where they belong. Now, when it comes to trigonometry, we work a lot with our trigonometric ratios. Not ratio. I don't know why I put it in there. Also known as just trig ratios. Oh my goodness, Benson. Which are side length comparisons. Specifically, based on an angle. You've heard of some of these trig ratios before. In fact, I already mentioned some of them in class because Eli mentioned some of them in class already. Sine, cosine, tangent. How does sine typically get shortened? S-I-N. Cosine? C-O-S. Tangent? Now you're never going to hear me reference them as sin, cos, and tan. And if you do, I am going to correct you every single time. Because they are sine, cosine, and tangent. We just get lazy and don't like to write them as often. These are the 3 trig ratios that you learned in geometry, but there are more than 3 trig ratios. There's actually 6. Not the inverse trig. There is cosecant, secant, and cotangent. Cosecant is shortened CSC. Secant is SEC, and cotangent is COT. Today you're going to see a little bit of review of stuff you did in geometry and a little bit new because you haven't seen these 3 additional trig ratios before. Now, we're going to do a little bit of a throwback to something from geometry. Do you remember in geometry hearing about SOHCAHTOA? Some of you maybe, some of you not. If you had me for Geometry B, you heard about SOHCAHTOA quite a bit when we were in the trig section because I said it for pretty much every problem. SOHCAHTOA is a memory trick to help us with our trig ratios, but before we get to actually exploring it a little bit more, there is something else I need to introduce to you, and it's this. That is a Greek variable. Does anyone know what it's called?
Is that theta?
It is theta. This is the trig variable theta. Now theta, it's just like any variable. It technically can be used for any unknown value in existence, but theta tends to be the Greek variable used for, or used to represent, unknown angles. This has nothing to do with Fibonacci.
I know, they started getting on, these notables were into stuff, and they started getting on for the Fibonacci thing first try.
You do tend to know some random things. I appreciate it, though.
No problem.
I appreciate it very much so. Okay. So, we are going to work with a right triangle. Why? Because trigonometry is built off of right triangles. We're going to talk about our trig ratios in reference to this right triangle, which means I need to reference one of my acute angles because trig is really never done with a 90-degree angle. It's always done with an acute or even an obtuse angle. The 90-degree angles tend to not be necessary for it. This is my angle of reference when I try to do my trig. Now, when I have an angle of reference, I generally then label my side legs with various words. The longest side of a right triangle, you should know that one, is the hypotenuse. The other 2 sides, the legs of the triangle, are where the O and the A that come into SOHCAHTOA come from. Do you remember from geometry what they're called? Adjacent and opposite. If this is my angle, you go across the triangle to find its opposite. You go next to the angle, the leg that's next to the angle, to find the adjacent. Now keep in mind that opposite and adjacent are specifically relative to where that unknown angle is, or known angle if you actually know what it is. If I had called the top acute angle theta, this would have been the opposite, and this would have been the adjacent. The opposite and the adjacent would flip-flop. The hypotenuse never does because the hypotenuse is always the longest side. But you do have to keep that in mind. Opposite and adjacent are relative to where the angle that you're focused in on is. So this is where SOHCAHTOA comes in. When you're working with trig, SOHCAHTOA is a memory trick for sine, cosine, and tangent. The S stands for sine. And trig always has to be of an angle. So after sine, cosine, tangent, cosecant, secant, or cotangent, the next thing is always going to be the angle. In this case, our angle is going to be theta. So sine of theta. This is the SO part. So S-O-H. S stands for sine, O stands for opposite, H stands for hypotenuse. And it tells you that sine, specifically, is the opposite divided by the hypotenuse. That, in theory, should sound familiar from geometry. S-O-H. First letter is the trig ratio, second letter is the numerator, third letter is the denominator. Ka stands for cosine. Again, always of an angle, so in this case, of theta. C-A-H. What do you think the A stands for? Adjacent. Goes on the top because it's the second letter. Divided by hypotenuse. That's the H. Following this logic. Thank you. Tangent of theta. SOHCAHTOA is therefore opposite over adjacent. Now those are the main three trig ratios. Those are the ones we're going to still use most often. That's why they're the ones that you learn in geometry, because those are the ones that are the most useful in basic solving things. But we're not in basic trigonometry. We're in FST. We're going to dive a lot more into trig than what you did in geometry. So we also have the other three trig ratios. Cosecant theta, secant theta, and cotangent theta. And we've already done every pairing possible of sides with sine, cosine, and tangent. But as we pair them up, because the ratios are side length comparison, there is one thing that we can do when we pair them up. For example, sine pairs up opposite and hypotenuse. Now, in sine, it's opposite divided by hypotenuse. But the other way you can pair up opposite and hypotenuse is doing what with it? Flipping it. That's where the three new ones come into play. The three new ones, which I will write this down shortly, they're known as the reciprocal identities because of the fact that sine and cosecant are reciprocals of one another. Cosine and secant are reciprocals of one another. Same with tangent and cotangent. Cosecant, secant, and cotangent are the reciprocal trig functions because of this relationship. Now, this piece of information is going to be one of the most important things that we do throughout all of trig, is recognizing which trig ratio is the reciprocal of which one. So, this is something you're going to want to memorize. Which one is the reciprocal of which one? First off, to memorize it, one of the things that I remind myself is the old ones always have to go with a new one. So, that narrows down some of the pairings. Tangents, I remember those ones go together. Tangent goes with cotangent. For the other four, only one ratio in the pairing will start with the word co. Sine doesn't start with co, has to go with something that does start with co. The new ones that start with co are either cotangent or cosecant. But remember, the tangents go together, which means sine has to go with cosecant. Cosine does start with the word co, so it needs to go with one that doesn't start with co. The only new one that doesn't start with co is secant, so it has to go with that one. And then again, the tangents go together. That's the memory I use. Other people have done different things. I've had people change this into Choshakau, kind of like Sohcahtoa, where they do cosecant is hypotenuse over opposite, hence cho. Secant is hypotenuse over adjacent, sh. Cotangent is adjacent over opposite, cow. You memorize it whatever way works best for you. But cosecant, hypotenuse over opposite, secant, hypotenuse over adjacent, cotangent, adjacent over opposite. Another way of writing this. Cosecant being the reciprocal of sine. To write something as a reciprocal, it's 1 over that item. It's not just a flipped fraction, it's 1 divided by the item is what gets you the flipped fraction. Secant, reciprocal of cosine, 1 over cosine. Cotangent, the reciprocal of tangent, 1 over tangent. And again, these three are known as the reciprocal trig functions. Today you're going to see 2 different types of questions. They're very, very similar to one another. But they are the basis of pretty much all of trigonometry. So, being able to do what we're doing today is extremely important. Hence the reason I'm not piling on more than just this. 2 different types of equations you're going to see. The first one is going to look like find the 6 trigonometric ratios or it might just say trig ratios for the triangle based on, and then it's going to tell you which angle to reference. And we're just going to call it theta. Some of them, they might give you a triangle and tell you the letter that corresponds with that angle. Got to give you a picture of a triangle to go with this. Specifically a right triangle. Which one of the angles is theta? I'll give you 2 of the sides. Or at least 2 of the sides. So when I ask for the trig ratios, I am looking for fractions. Simplified fractions, more specifically. I'm looking for sine, cosine, tangent, cosecant, secant, and cotangent. Starting off with sine. Sine is what side over what side in a right triangle? Think of your SOHCAHTOA. Opposite over hypotenuse. What is the opposite in this triangle? We don't know. This side should be our opposite. We don't know it. Is there a way we could find it? Yes. What? Pythagorean theorem. I'm going to call that side x. X squared plus 48 squared equals 50 squared. Why did I put it in that order? Because 50 is the hypotenuse, and the hypotenuse has to go in c squared. X squared plus, you got a calculator, right? If not, you should start grabbing one pretty much every day. 2304 equals 50 squared. 2500. 5 squared is 25. 2 zeros. Subtract the 2304. 196. To get rid of the squared, I take the square root. X is the square root of 196. Can I simplify that? Yeah, what do I get? It's a nice one. 14. Sine is opposite over hypotenuse. So sine is 14 over 50. Can I leave a fraction like that? No. Simplify your fraction. What do you get? 7/25. That's sine. Make sure I can tell which ratio is which. If you organize it well, you don't have to box it in. You don't have to rewrite 7/25 is equal to sine of theta. Just make sure I can tell what's what. Ooh, I wrote that too high up. Oh well. Cosine. So ca. C-A-H. So cosine of theta is equal to? Adjacent over hypotenuse, aka 48 over 50. Can I leave it like that? No. What do they both divide by? 2, 24/25. SOHCAHTOA. I move on to tangent. Tangent's what over what? TOA. T-O-A. Opposite divided by adjacent. 14 over 48. What do they both divide by? 2 again. 7/24. How many answers should I have? 6. Find the 6 trig ratios. I need the other 3. Which one is the reciprocal of sine? Cosecant. Sine doesn't start with a co, so I know this one does, so it has to start with a c, and it doesn't go with cotangent, because the tangents go together. So CSC. Now you can go through and you can think about cosecant as hypotenuse over opposite, or I find it easier to think about cosecant being the reciprocal of sine. It's fewer things to memorize. And if it's the reciprocal of sine, what's it going to be? 25/7. Which one's the reciprocal of cosine? Secant. What's secant going to be? 25/24. Cotangent. So reciprocal of tangent is going to be 24/7. That's That's one type of problem you're going to see today. Doable?
Yeah.
The second problem is going to look very similar. It's just giving you different information. Find the 5 remaining trig ratios given tangent of A is equal to 2/11ths and A is an acute angle. If I give you a trig ratio and I ask you to find any other trig ratio, the easiest way to work with it is to work with a triangle. Specifically, a right triangle. In that right triangle, one of my acute angles is going to be angle A. Doesn't matter which one. I'm going to call that one A. Now this right triangle doesn't actually exist. It was never there, but it's going to help us find what we're looking for. Because we know that tangent of A is equal to 2/11ths. What do you know about tangent of a right triangle? It is the opposite over the adjacent. Which means I can label my triangle where 2 is on the opposite side and 11 is on the adjacent. Provided I'm going from angle A. Which side's the opposite? The vertical, the horizontal, or the angled one? Which one's the adjacent? Vertical. Which means this is my hypotenuse. I'm missing the hypotenuse. I need it. How do I find it? Pythagorean theorem. A squared plus b squared equals c squared. 2 squared plus 11 squared equals x squared. 4 plus 121 equals x squared. X squared is 125. Take the square root. X equals square root of 125. Can I simplify the square root of 125? Yes. Does that mean take the square root of 125 in my calculator? No. That's evaluate. I want to simplify. To simplify a square root, I figure out what perfect square it divides by. Divides by 25. 25 times what? 5. So it's the square root of 25 times the square root of 5, which simplifies to 5 root 5. And now I go to finding my trig ratios. I tend to start with sine. Sine, what has to come after the trig? The angle. In this case, the angle is not theta. What's the angle? A. Sine is what over what? Opposite over hypotenuse. Opposite was 2. Hypotenuse was 5 square roots of 5. Can I leave it like that? No. How do I simplify? Multiply top and bottom by square root of 5. I get 2 square roots of 5 over why 25? Square root of 5 times square root of 5 is square root of 25, which is 5, and so it's 5 times 5. Again, as long as I can see that it's organized well, you don't have to rewrite that sine of A is equal to that, but it's got to be organized in a way I can tell what's what. If I can't tell which ratio is which ratio, I'm going to have issues. Okay. After sine, I tend to do cosine. Again, of A. Cosine's what over what? So, ca 11 over 5 root 5. Can I leave it like that? No. Multiply the top and the bottom by? Square root of 5. I get 11 root 5 over 25. Can this sometimes simplify further once it gets to this point? Yes. What would have to simplify? The whole numbers. 11 over 25 doesn't simplify, nor did 2 over 25. But if they do, do it. I am not going to do tangent next. Because we already know it. I gave you tangent. Don't tell me what tangent is when I gave you what tangent was. Can you? Sure. But there's no need to. Okay, which one's the reciprocal of sine? Cosecant. Here's the thing. When you're doing the reciprocals, pay attention to what your most simplified form is, of its reciprocal that is, and the original form. If I flip sine's final answer, I get 25 over 2 root 5. Will I be able to leave it like that? No, I will have to rationalize the denominator. But look at the original form. If I flip that, what's it going to be? 5 root 5 over 2. Do I have to simplify that? Yes. It can't simplify. Sometimes you're going to be better off flipping the form before it was simplified, because it'll be simplified. Now granted, still double check if the 5 and the 2 would simplify, but it won't. If it simplifies here, it would have simplified over here. If you did that first, then simplify the version where you simplified the 2/5. Or flip the version where you already simplified that. Okay, what's the reciprocal of cosine? Secant. Flip the original version or the simplified version? Original. Because the original was before you rationalized the denominator. Can I simplify it? No. What's the last trig ratio? Cotangent. Cotangent of A is equal to 11 over 2. Because I gave you tangent was 2 11s. How are we feeling about writing the ratios? It isn't particularly challenging. You got to rationalize your denominators. You got to make sure you identify your sides correctly. You got to simplify fractions. But it is the basis of so much that we do that we are not doing more today. I want you to focus on this. Page 795, day 1. Question. Numbers. 3, 4, 13 through 20. I don't believe they all ask for all 6 ratios. It's been a bit since I've done this problem. I didn't make all brand new answer keys this try. But, like I said, is the basis of everything that we do. So, I need you to get to practice. No, the book is not online. Nope.